Okay, so we left off with the first reflected ray drawn from the shamrock into the viewer's eyeball, and the incident ray, the incoming ray from the sun, would be here. And as you could tell, I had drawn the dashed line that goes along with the normal, so you can see that the angle of incidence over here would be equal to the angle of reflection from that normal line. For viewer number 2, or this second eyeball here, it came out kind of weird on your note helper. That's an eye. The reflected ray we're going to draw as its straight line path off of the shamrock and into the viewer's eye. So take your straight edge and do that straight line. And the incoming ray would be from the sun. And again, if I were to draw that normal perpendicular to the surface, dash line, you can see that the incoming ray, incident angle, is equal to the reflected angle. Okay, it's kind of difficult to see here. And then the last reflected ray into the eyeball would look like this. And the incoming ray would be this third light ray here. So that's the backwards, tracing the rays backwards to complete the ray diagram. We're again looking at those straight line paths and incoming and reflected rays into the viewer's eyeball. So as you practice, go ahead and take your straight edge and draw the straight perpendicular lines to the surface. This first surface, although it's a slant, you can still turn your paper and draw that perpendicular line like so. As you move your straight edge onto the next dot, you can draw the next perpendicular line like so. Okay. On the curved surface, it works the same way. You might be thinking about how curved mirrors would differ from straight mirrors. When the object strikes the surface, we're going to do still the perpendicular line at that point. As you travel along, make sure you square up your 90-degree angle and draw your perpendicular line and proceed all the way through the end of this curved surface for practice A of drawing the normal. Okay, for object B, we want to pinpoint where this bug is. You can see that I've already started you off with the reflected ray into each viewer's eye. So you're going to just extrapolate that backwards and see where they all intersect to locate the position of the bug. The instructions are as follows. 3 eye locations pictured can see a bug. So the bug's going to be somewhere over here. We're going to see exactly where by looking at where the light rays diverged from, where they all started from. Use the given light rays, that's these, to locate the position of the bug. Add several light rays from the source, that's the sun up here, that would be needed in order to see the bug. So let's do the reflected rays first. Take your straight edge and let's extend this first viewer's light ray backwards. And then you'll move along and let's extend the second viewer's light ray backwards and the third viewer's light ray backwards. You can see that they all intersect or originate from one point. That's where the bug is. However creative you're feeling in your soul, you can draw your bug how you wish, but mine is a ladybug. To draw the incoming rays, this one, again, you would have a line that's going to be equal in angle as it came in versus how it went out. So there's your incoming light ray. I did yellow because, yeah, the sun. We pick yellow a lot. For the second viewer's light ray, the incident ray would be like so. Again, if I could draw the normal, dash, 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 dash. That perpendicular line would totally show us that the angle on the right, the incoming angle, equals the angle on the left. So erase that away and draw the last incoming ray, like so. So the sun is Shining its light rays onto the bug, it's going to strike the surface of the bug, reflect off at the same angle, and into the viewer's eyeball. Last but not least, practice letter C. At a concert, the performer is lit with spotlights in the ceiling. We're first going to draw light rays on the diagram to indicate how an audience member can see all of the performer's body. So we want to make sure that there's a light ray coming into the person's eye from the top of her head, and there'll be many more all the way down to the bottom of her feet. We're going to just do the one that strikes the top of her head and the one that strikes the bottom of her feet, so that we can then assume that there's going to be several other light rays, in between that would also be doing the same thing. All right, so here is the viewer's eyeball. Let's first draw an incoming light ray to the lady's body, and then the reflected ray would be like so. Because this one struck the middle of her body, we can then therefore say, okay, here's another one that would strike her. It's really hard to draw a straight line, top of her head, and then be reflected. Yeah, I'm not going to do that. Use your straight edge to draw the straight lines. The next question is, can the audience member see the light on the ceiling? So if this is the ceiling right here and the light is up there, the audience member, we can say, does not have a direct line of sight because of this slanted portion. The light that's emanating from the luminous object is not going to have a straight line path to travel from its source to the viewer. And letter C, can the performer see the light source? Well, let's see if our straight line path checks out. From the light source to the person, yes, there is an unobstructed path, so the lady will be able to see the light. That, class, is our lecture on reflection. The next thing that I would like you to do is to return to the hub folder and take a moment to go through the Chromatron link that I've given you that has you start to discover the idea of reflection when you have different angled reflective surfaces. That's going to get us prepared for our gizmo that we'll have on Monday, and we will reconvene then.